No, that's right. 1 is not a prime number. Good job, team. So, prime numbers divisible by 1 and themselves, that's that. Now, the real part of this lesson that is interesting is the rational roots theorem. Okay, the Bible says this. I've lost some of you. You're used to tuning me out. Double speed? Should I talk faster like this? No? Okay. The Bible says this. So cool. You will know that you are my disciples by the love that you have for one another. And then the Bible lists out the fruits of the Spirit, right? And so you can see like the fruit of someone's life, and you can assess the fruit in your own life and be like, am I on the right track? Am I going in the right direction, right? The Bible gives you those things, and then you kind of test them out. You kind of look at it for yourself, right? The love, the joy, the peace, the patience, which we don't have for people all the time, right? And so you kind of do that. In math, sometimes we are at a loss, and we have no clue what to do with graphing things that look like this. Right? Like, what are the zeros going to be? I don't know. There's no, like, equation for solving cubed root stuff. And so it would be much easier if you had, like, a list of things to look at. Okay? Just like we look at the fruits of the Spirit, we're like, yeah, I'm doing great on these areas. Man, there's really no fruit in the self-control part. The rational roots theorem gives you a list of possible roots. And in fact, it gives you all of the possible roots of an equation. All is a big word. I usually don't use the word all because all and always and forever doesn't work, right? There's always exceptions. But in this case, if there are roots that are nice numbers, and when I say nice, I mean rational numbers. So it's a fraction, or like an integer, or a whole number, or a counting number. If this equation has good zeros, right? Numbers that I can plug in that are 0, that are like friendly and not square roots and not ugly things, they will be in this list. So what you do is you take all the factors of your constant, which is 5 in this case, and you divide that by all of the factors of the highest power coefficient. So, when is this useful? If I ask you to graph this function, y equals this, the first thing that you would need is to find the zeros, right? Because then you find the zeros and you can do a little, right? But you don't know where to start because it's a cube. So we use the rational root theorem, which is this, to find all the possible zeros that would be friendly. Okay, this is how it works. What are the factors of 5? What number is going to 5? 5 and 1. So I'm going to do plus or minus 1 and plus or minus 5. I'm going to divide that by the factors of this number, which is 1 and 2. And now I'm going to make a really ugly list of all the possible options there could be. So I'll start with this one. Positive 1 divided by positive 1 is 1. Positive 1 divided by negative 1 is positive 5. Oh, sorry. Positive 1 divided by 2 is 1/2. Positive 1 divided by negative 2 is. Now, because these all have plus minuses, I've already included minus 1, right? Minus 1 divided by 1 is negative 1. So you kind of don't have to do all of them because they'll be included. So now 5 divided by positive 1 is 5. 5 divided by negative 1 is negative 5. 5 divided by 2 is 5/2. 5 divided by negative 2 is negative 5/2. I don't have to do the minus ones because I've already done plus or minus here. Just make sure you get all of them. So if any zeros will exist for this, or any roots, that's why it's called the rational roots theorem, they're in this list. So if they're nice numbers, they can be written as a number or a fraction. They're in this list. So the question will say, find all the rational roots. And now we suffer. Now the only way to know which ones are actually roots is to plug them in. So you can plug in 1. Negative 1. 1/2. Sorry. Negative 1/2. 5. Micah.
You sent it to the verbiage.
Micah has negative 5. And I will take these 2. You need him back.
Well, you did say.
Hey, you guys have additional. I did that. God bless thee. What? Sorry, that just.
Who is
I'm Pentecostal. We clap our hands in worship.
I walk into that class and there's like a guy getting stabbed in the forehead. And I'm like, what? Okay, so I'm going to use the. Hi, welcome back.
Oh, wait,
I'm going to use this. No, you can plug them in, but I'm going to use this because it's easier. Micah, you're plugging in negative 5 to that. You also got to sign all these other problems.
But I thought that was for your. Aren't those
It's
yours?
not funny. 55, 60. Nope. Okay, so I can plug those in really quickly using the synthetic division trick that we learned. No.
No.
Oatmeal cup is gone.
That's so sad.
Oh, legacy.
Well, at least you have an excuse not to eat.
That was glass.
No, that's right.
Oh,
Bye, my
can't eat it from the.
You all know what to get on.
Okay. Now I'm going to get all sorts of mugs for Teacher Appreciation Week. If I am appreciated, I don't know. We'll see. Okay.
I'm gonna get you oatmeal stuff.
That's not a juicy thing. It's a toilet muck. I was like, that's.
I thought you were going to say toilet plunger. And I was like, why are you getting me a toilet plunger? Is the bathroom that bad? Okay, this is 2, this is negative 5, this is 2, this is negative 5, this is negative 3, that's ugly. Is that right?
How do you know if it's right?
If this is 0.
Oh.
This is 15 halves, so that's going to be
No.
25 halves. So that one's not right. Okay, what'd you get for 1? Was it 0? Okay, gone. Negative 1?
No.
Not 0? 1/2?
You're just plugging into the X, right?
Yeah, just plug it in for the x's, or do this. So negative 1/2, or 1/2 didn't work?
I didn't do it that way.
If you just plug it in, it'll work too. No. Gabby? Victor?
No.
None of these work? This is a horrible example problem. I don't know. Let's graph it on our calculator, see if it has any rational roots.
Can you use the calculator for everything?
Yeah, until you get to calculus and I walk in and I'm like, no calculator! And then I don't let you use calculator for most of it. Yep. Because it's a crutch and you don't need it.
What's it? Never mind.
Alright, so it turns out, this is a horrible example. After testing this, none of them are rational roots. It's just an ugly, weird fraction, non-fraction thing right there.
What is that?
I don't know. I guess we could find out. What if one of the ones I did was wrong?
What if?
Yeah, it's negative 1.74.
What
which
is
is
it
not
supposed
many.
to look like?
Well, it would just go through a nice number, and that's how you would know. Okay, so that's the rational root theorem. Up to this point, they're just going to have you list this list. You don't actually have to solve for it yet. So that's cool. All right, that's 117. Woo.